Making a tall tower sounds quite straightforward, and usually people think in just squares and stacking them up one on top of the other. But if you just think about the bridge, the strength of this bridge is in the shape that we've used. So those triangular prisms are really important. And what you notice about a simple sketch like this is these are squares or rectangles, they're not triangles. So the three-dimensional version might look something like this, look. So let's rotate the screen around a bit there. So there's the three-dimensional version, and no triangles present. As soon as we try to put a bit of force sort of sideways on the thing, it just collapses over, so it won't keep its shape. Yet the triangular prisms do maintain their shape. So this isn't a strong structure at all, and it flops about all over, even though it's made of exactly the same size tubes and with the same rods as well. We need to strengthen that structure, and we do so by putting in diagonals. So let's have a quick look at that. Turn it on its side, get rid of that. Now the odd thing about a diagonal is it's not the same length as these other tubes. So if we were to try and put an ordinary tube in as the diagonal, so same length as before, it'd be a better one than that, same length as before, let's find a nicer one. They're all a bit old, these ones. Same length as before, then you would distort the shape by creating the diagonal. So the tower wouldn't be straight. So what we need is quite simply a longer tube. And the way to do that would be to use paper, A4, A5 paper. So A5 paper just like before, but use it in that orientation when you use the rolling rod. So the rolling rod rolls a long tube, and then match up the long tube with the exact length of the diagonal. These paper turned sideways will make a long tube. It will not be exactly the right distance, and it's because we haven't allowed for exactly where the punch hole would be. So you've got to think about this. It can be done, and we'll do it in the next little video clip.